So before this, our class, we have finished until the temperature only, right? So this chapter we have temperature and heat. Okay. So before we continue the tutorial of heat, we must finish up the lecture for heat. Okay. So the learning outcome today is to understand how to calculate the heat and then do the tutorial 8. Okay. So what is heat? Heat is energy transit between two systems at different temperatures. Anyone know what is heat? Not sure. Okay. So heat flows from the system at high temperature to the system at low temperature. An experiment by Joule shows that the quantity of work done on a system or the same quantity of heat flowing into a system causes the same increase in the system internal energy. So heat is measured in joule or calories. 1 calorie is equal to 4.186 joule. Okay. Next, for many substances, under normal circumstances, the internal energy of a system increases when its temperature increases. Q proportional with changes of T. As long as no phase change occurs, for example, from solid to liquid. So we can say that when the temperature increase, okay, the energy also increase. For you, how you increase your energy? Anyone?
You eat.
Yes, when you eat, you get hot, right, your body? You become heaty, right? So when you become heaty, what you need to do, you need to drink. If not, your face will become pimples. Pimples come out, or your body also come out pimples or rashes. Okay, so from this concept, you can say that when your body is heated by eating things too much, you need to lower down the temperature by drinking. Okay, drinking, is it hot water or cold water is good? Good. Workout mentioned by Bunny. Warm water. Okay. Warm or cold cannot. So, cold or hot cannot. So, drink warm. Okay. Why it is not good to drink cold water? When you eat more fat, for example, okay, like chicken and so on, right? So chicken have a lot of fat, especially when you eat the skin. Some people remove the skin, okay? If they eat KFC or what, they don't eat the skin. They remove it and eat the inside the meat only. Okay. So for those who eat all this chicken, okay, after that After that, your body will become heat, right? Okay, this is same as if you take a lot of vitamins also. Okay, those who like to work out, they also take some workout, what you call that, protein, right? Protein to build up some muscle. Whey protein, yes. So they will become heaty also, right? So they need to drink a lot of water. Those people who like to eat a lot of vitamins also. Morning maybe vitamin C, afternoon vitamin E, and so on. If too much vitamins, you may need to eat. You need to drink a lot of water also. Okay. So just now mentioned if you eat fat with the ice, what will happen? The fat will be easily clump into one. Okay. So clump into one and difficult to be dissolved or go out from your body. So it becomes fat here, fat there. Arterio. This one I don't know. To block the heart, is it? Maybe lah. Okay. So, since you are still young now, practice a good healthy diet. Okay, maybe you cannot prevent yourself from eating many things because you like to eat. So you cover it with a lot of jogging, a lot of exercise, or go to gym. Okay? So this will make your body less heat. So when less heat, easily any toxin can come out from your body. Okay. So heat capacity is the amount of heat energy required to raise the temperature from an object of any mass by specified amount. Okay. In SI, heat capacity symbol C is the amount of heat in joules required to raise the temperature 1 Kelvin. So from there, we will have a formula Q equal to C changes of T, where C is the heat capacity. So to calculate the energy, okay, to calculate the energy, you must know the heat capacity value to substitute into here. And then the changes of T is new T minus original T. Then you get changes of T. So Q is negative is if heat flows out of system. 1 gram of water has a heat capacity of 4.18 joule per Kelvin. Specific heat capacity is the amount of heat energy required to raise the temperature of a body per unit of mass. In SI unit, specific heat capacity, symbol C, is the amount of heat in joules required to raise 1 kilogram of substance 1 Kelvin. So this is another formula. C is equal to C per M and equal to Q per M changes of T. So Q will become equal to MC times changes of T from this formula. Okay, so anything in the box is the formula which will be provided in the formula sheet. So look at this example, a saucepan. For a while. Okay, got some noise just now. A saucepan containing 5 kilogram of water. You know saucepan, right? A pot. Okay. Containing 5 kilogram of water initially at 20 degrees Celsius is heated for 10 minutes over a gas burner. The final temperature of the water is 30 degrees Celsius. Okay, so from here you can see that the changes of T is from 30 minus 20, which is 10 degrees Celsius. That is the changes of T. What is the internal energy increase of the water? So, internal energy is Q. Okay, how much? So, use the formula. First, calculate the temperature change first. In any question, there are marks to do this changes of T. Okay, there are marks. So, don't just directly put as 10 degrees Celsius. Okay. Changes of T might get 1 mark from there for the working. Okay, next is the increase in internal energy of the water. Okay, what is the increase? So, changes of U equal to Q equal to C times changes of T. Then equal to MC times changes of T. Okay. So, after that, C is the specific heat water, C. 4.186 given in the question. Substitute here in the small t as small c. Okay. M is the mass, 5 kilogram. Okay, 5 kilogram of water. If 10 kilogram, you put here. But 10 kilogram not so logic. 10 kilogram is so much. Okay, unless you have a very big pot. So, saucepan is small only. Okay, pot will be bigger. So, the amount must be suitable also. 5 kilogram also consider big, right? Big amount. Like the what you call that? Flour or what, right? So normally flour or sugar they sell 1 kilogram, 1 packet. So you imagine 5 packet of the flour become 5 kilogram. Okay, so that is heavy. Okay, so increase of energy in the water is 209.3 kilojoule. Okay, understand? Simple only, right? This one just substitute with the formula given. Okay. Okay, next we go to the phase transition. Phase transition occurs whenever a substance changes from one phase, from solid, liquid or gas to another. Okay. So, for example, sugar. Sugar is solid, right? Sugar. Small particles, right? That is considered solid also, even though it looks like small. So, solid or sugar, when you put into the saucepan, you can heat it without putting any water, right? For what you do that? Anyone know? Sugar and heat up in saucepan. To become what? Good. Will become caramel. Who don't know what is caramel? Caramel is the sugar which got burnt a bit. Got some... the color become brown. Squid Game. Oh, that one I don't know. But nowadays, what is the famous cake nowadays with caramel? The famous cake nowadays is salted caramel. Caramel is sweet. Some people don't like very sweet like me. I also don't really like so sweet. So salted caramel is okay because added with salt. So it will be a bit salty, not so sweet. Okay, maybe children like this very sweet things. Caramel coffee. Okay. This one I'm not so sure. Normally cream caramel. The pudding. You have eaten? Nowadays expensive. This one in the market, night market also maybe one slice 3 ringgit ah. If in Shopee Mall 10 ringgit ah. So if you know how to make yourself, better you make yourself. So to make the cream caramel, normally you need to heat up the sugar. No need to put water first. Okay. Then the sugar melted a bit, put water a bit can. Then it becomes the bottom of the container. Then you blend everything to become pudding. Use blender also can. Oil on it and then steam everything. So it is 5 minutes work. Very easy. Okay. If you don't have oven, you can use steamer or microwave oven also. Okay. So that is just advertisement before you get sleepy. So these are the phases. Solid. After that become liquid. After that become gas. Gas you cannot really see. Okay, it is transparent. If you heat up the sugar just now. Sugar from solid become liquid. Liquid in terms of caramel. Okay, after that the gas is the one flowing on top of it. Okay. So suppose we change ice at negative 25 degrees Celsius into steam at 125 degrees Celsius. A graph of the temperature versus heat is shown below. So temperature from negative 25, which is the ice, go into ice plus water is 0 degrees Celsius. And then water is from 0 to 100 degrees Celsius. After 100, it turns into water and steam. But from water and steam, it maintains. When the transition happen, okay, for this is solid and liquid, ice and water. For this is water and gas. So during this transition, the heat will maintain. The temperature will maintain. Temperature maintain at 100. But heat changes. Okay, heat changes. During the two-phase transition, heat flow continues, but the temperature of the two-phase mixtures does not change. Like here also, from ice go to water, temperature is 0, no change. Okay. Sometimes you can be asked to do a short conclusion. Okay, how to do the conclusion? During the two phase of mixture, what can you conclude for the temperature changes? So what can you conclude? You can conclude that the temperature maintain no change during the transition of solid to liquid and during the transition of liquid to gas. If you understand, you can do your own sentence. Okay? But the heat change from here 805 until 3061. Sometimes you have analyzed the characteristics given. Characteristics is graph. Okay. Analyze the characteristics given and state the temperature. No. State the heat changes during the transition of water to steam. So heat changes is 3061 minus 805. So in any figure or any sentence that you get in the slide, you must know how to manipulate it. How can this become a question? For example, or in this whole topic, which question is possible for the lecturer to set? Then you will be focused. Okay, because we have too many formula to do. Too many chapter also. Later, you you will be not sure which part will come out. Okay, but don't worry, all the formula is provided. Next is the latent heat. Latent heat L is the amount of heat per unit mass required to change the phase of a substance. So latent heat formula L equal to Q per M. So Q is the energy just now. Therefore, if you want to calculate the latent, you need to calculate the energy first, then substitute into this formula. Latent heat of fusion is the heat per unit mass needed to produce the solid-liquid phase transition. The latent heat of vaporization is the heat per unit mass needed to produce the liquid-gas phase transition. Okay, wait for a while. Okay.
Going to do a little demonstration today. When water is heated, it will raise in temperature. Now I'm going to show you the temperature of this water right now. Okay, about 16 degrees Celsius and 62 Fahrenheit. Okay, now when I heat this water, it's going to increase in temperature. It's going to be gaining sensible heat. It gains sensible heat, and then it's going to reach the boiling point. It's going to stop increasing in temperature when it hits the boiling point. It's not going to increase the temperature until it evaporates all the water, boils all the water that's in that pot. So I'm going to turn on the burner under this and let this warm up, and we'll see how this works. Okay, we're starting to heat. We're getting up to about 84 Fahrenheit or 30 Celsius. So you can see it's warming up. We'll see when it gets up to the boiling point what happens. Okay, 74, 76, 174. Notice we're steaming here, what looks like steam coming off. That really isn't. It's about 35 degrees in this room right now. So you're going to see this vapor coming off even before it boils. Okay, 90, over 90 degrees, 202. We're starting to show some boiling. Yeah, 99.3, maybe we're boiling at a higher temperature than I thought. This is not distilled water, so sometimes you can't be sure of what temperature it's going to boil at. Distilled water you can. I notice it's showing 215 now. But now it's boiling at a very vigorous rate. And we're showing a steady number. Going by Celsius. So it's showing fairly steady. Now I'm going to turn this down and let's see if it gets cooler. Now here you can see we're boiling at a lower rate, but we're still running right around that 100 degrees Celsius. Now I'm going to crank it back up again. You can see it runs about that same temperature, even though I've turned the heat way up. So there's no real temperature difference between a fast boil and a slow boil. Now, what's going to happen here, this is going to boil until there's no water left. And let's watch what happens then. Now, here you can see we're almost completely out of water. If you look close at this, you can see it. It's right at the bottom, and we're still running right close to that 100. Now, here's what's going to happen. That water is going to go away here in a minute. There's a Fahrenheit reading. Now you can see we're starting to increase because a lot of the water, there's just a tiny little bit left. And it's having trouble absorbing all the heat. Now you can see it's really going up now. We're at 360, 70 Fahrenheit and almost 200 Celsius. Because the water's gone, it's not absorbing heat anymore. It's all turned into steam. And so the pot, which is the only thing that's absorbing heat now, is now increasing in sensible heat. Now you leave it on here long enough and it'll burn that pot up. You see we're almost to 500 degrees Fahrenheit and 260 Celsius. So I'm not going to leave the pot on there because I don't want to destroy my pot. But that's how that works. As soon as that water's gone, this thing is going to start heating up to beat heck. Okay, that's it on that one.
Okay, understand about the during the transition, the temperature don't change, but after all the water is gone, then the transition have finished, temperature increase. Okay.
Okay, miss.
Okay, so now we continue with the slide back. So after latent heat, there is an example. A jewelry designer plans to make some silver charms for a bracelet. You know what is charm? Silver charm. Like the Pandora, something like that. Okay. For bracelet, if the melting point of silver is 960.8 degrees Celsius, how much heat must the jeweler add to 0.5 kilogram of silver at 20 degrees Celsius to be able to pour silver into the mold? If not, if the silver not melted, how to pour into the mold, right? Okay, understand right the concept? Okay. For example, you are making pudding or pudding or jelly. Jelly. Jelly who have tried how to make? There is one in the packet with powder type. Or the one which looks like hair. Looks like hair but transparent. That one also to make pudding or to make jelly. Okay. So once you heated the jelly with the water, okay, you need to put with water. The powder type or the hair type. Okay. After you heat this, you cannot put sugar directly. Until all the jelly dissolve, then only you can put the sugar. If you put in the beginning the sugar with the water, what will happen to the jelly? Jelly will be clumped. Not nice. Later you can bite it. Jelly suppose it should be melted when you eat. So you cannot bite it. Okay. So sugar must be put last. Okay, after all have dissolved in the water. Then you can put. So here, you want to put in the mold. What is the use of the mold? To make heart shape, round shape, or whatsoever. Okay, silver charms normally have many small, tiny shape. Bell, teddy bear shape, love shape, or round shape. So there are many different shapes, so you need to use mold to do it. So this silver should be poured into the mold until become cold. Then take out from the mold, put into this bracelet. So maybe one bracelet should have 5 charms. Normally the number is odd numbers, 5 or 7. I don't know for your belief. But mostly they follow the flower. Flower also, the petal are 5. You cannot find petal of flower with 4. I don't know if have special. But mostly plants or flowers made from God, the number are odd number. If you don't believe, you go to the park after this, you count. One flower have how many petals? Is it odd number or even number? Okay, that one advertisement only. Okay, so specific heat of silver, C, is 0.235. Latent heat of fusion, LF, is 88.3 kilojoule per kilogram. Okay. Maybe Lazada or what, don't know lah. Okay. So now we look at the solution. Temperature change of solid silver is. Okay, so from 960.8 degrees Celsius, want to go to 20 degrees Celsius. Okay, so it's 940.8 degrees Celsius, the changes of T. Okay, sorry. So to calculate the total heat flow into the silver, must use Q equal to MC changes of T plus M times LF. L is the latent fusion, heat fusion. So latent heat fusion given in the question, 88.3 kilojoule. Okay, so for this calculation, better you make a bracket. Because sometimes student will plus wrongly here. So in mathematics, you have learned, right? You must do the calculation for multiply first. So here also multiply, then only total you plus. Sometimes student careless mistake. So if the formula is already given in the formula sheet, there are no marks here even though you write here. Okay. So you are writing the formula to help you to substitute later. Don't be lazy. Okay. Later you don't type, you don't write this MC changes T. You also don't know what figure to put here. Okay, so M is 0.5 kilogram. C is 0.235 specific heat of silver. If for other thing, other value, okay, you must get it from the table if not in the question. specific heat value. Okay, after that, changes of T already calculated up here. Substitute here. Plus with M times with LF. M is 0.5 kilogram. But the charm letter, okay, the charm letter, how many kilogram? You know or don't know? Does it mention in the question? Final product. This guy, this designer want to make this silver charm. Okay. But does the statement mention what is the weight? What is the mass of the silver charm later after finish? After finish design, what is the final final mass of the silver charm? Not mentioned, right? Even though you use 0.5 kilogram of silver, maybe you don't use all to make this charm. Okay, understand what I say? Who have gone to the jewelry shop? Nowadays, guys also buy, right? Buy for girlfriend, buy for mother. Go to the jewelry shop. So, the price of the charms or bracelet or what else? Ring. The price depend on the gram. 1 gram how much? Nowadays gold how much 1 gram? 260 something I think per gram. So if 0.5 kilo, die lah. Expensive, right? So normally it is in grams only. Okay, not in kilo. Too heavy later who want to buy? Want to wear also very heavy. Want to go anywhere carry the bracelet very heavy, right? So if question asks you, what is the estimate grams or estimate mass of the finished product? Later you don't know. If the mass here is 0.5 kilogram, so finished product should be how much? But not mentioned, right? How many the charms in the bracelet? Got 10 charm, 8 charm, 7 charm, how many? Not mentioned. If mentioned, then you need to count. Okay? Okay, so for the summary, the heat not much in the lecture, only that. Okay, so as a summary, thermal expansion, most objects expand with increasing of temperature. Okay. What else? Heat capacity. Change in temperature proportional to C equal to Q per changes of T. So change of temperature proportional to change in heat energy. After that, specific heat. Heat capacity per unit mass is equal to C equal to Q per M changes of T. Phase transition occurs when a substance changes from one phase to another. Heat flow continues, but temperature is constant. Okay. So, these are the further reading for the this chapter. Okay. So now we will go to the tutorial question. Okay, previous class we have done the tutorial 8, number 1 until number 5, copper washer. So today we will continue number 6 onwards. Okay, try to do number 6 first before we discuss about it. If 125.6 kilojoule of heat is supplied to 5 times 10 to the power of 2 gram of water. 10 to the power of 2, how much? 100, right? So actually this is 500 gram of water at 22 degrees Celsius. What is the final temperature of the water? The specific heat of water is 4.186 kilojoule. Kilogram negative 1, degree Celsius negative 1. That is the unit. Okay, unit a lot. For the specific heat, the unit is a lot. Okay, try to do this. Want to open formula? Okay, can put at one side. So we are doing number 6. Okay, try to settle question number 6. So first change the mass of the water to kilogram. Change to kilogram first. Wait, 0.005 times 10 times 10 to the power of 2. Change to kilogram. So you want to find the T. Changes of T equal to T minus TC. TC is 22.
Coffee. Sabay. Sabay.
6.82. Oh, 82. I also confused. 82 correct. Okay. Wait, when I save, it was small. So I need to zoom. So the answer is 82. Aiyo. Suppose when I save, I must zoom first, then I save. Okay. So refer to the question. Okay, correct. Jim, sorry. Lim Jin Yan, 82. Tong is 80.0096. Okay lah. And Bani, 82.01. Okay. So, first step, you need to change the mass 5 times 10 to the power of 2 from gram to kilogram. Change first. Because later want to substitute in the formula. Okay, cannot be in gram. Later all wrong. Next, you can jot down the C. Specific heat of water given. 4.186 jot down. And then you jot down the temperature given. 22 degrees Celsius. So that is the TC. Original T don't know. So changes of T formula is T minus TC. So what is T? From this formula, Q equal to MC times with changes of T. Therefore, changes of T equal to Q per MC. Okay, wait, I open the formula. Because wait, I want to see the manipulation for formula. So for the temperature and heat, Q equal to C changes of T have. So we don't have the changes of T at the left. So consider already manipulated. Changes of T equal to Q per MC. Original is this. Q equal to MC changes of T. If you directly use the original formula, you don't have marks for this. If you already manipulate, means you bring one to the left side, then whatever that you want, you don't want bring to the right side. So this is manipulate the formula, got marks. If just this, directly use, no marks. Okay. Okay, so most can do already from the chat here. After Bani, Ella Alam and Lim Wei Huan. Okay. So changes of T we don't know. So we must put in terms of T minus 22. Okay, so later after calculate all this, you get 60. 60 plus 22 is 82 degrees Celsius. Okay, so don't forget the unit. Some lecturer might minus half mark if no unit. So half here, half there, finish ah. Okay. Okay, so try to maintain the marks that you should gain. Okay, suppose you should get 10, you must get 10. You don't be lazy to type here, to write things which will make you lose mark. Okay, number 7. Okay, continue number 7. A 0.4 kilogram aluminium tea kettle. Why this tea kettle one? Tea kettle contain 2 kilogram of water. So between tea and coffee, which one you like to drink? Tea or coffee? For youngsters. For me, old lady, I drink tea. Coffee I drink but not in the... At night cannot sleep later.
I like both, miss, but I prefer tea.
Oh, like both but prefer tea. Is it Chinese tea or black tea?
Teh tarik. Wait, no. Tea, if you're talking about tea, is black tea.
Teh tarik. Black
Nam tarik.
tea is like... No, black tea is what you call that, Earl Grey tea. Something like that lah. Black tea is not the same as the normal tea. It is more healthy. Like Earl Grey tea. That is my favorite. They said for slimming must drink oolong tea. For Chinese, maybe they know. To be digest, normally they also drink Chinese tea or green tea, right? Green tea. Green tea after lunch, drink green tea can be slim. People say, I don't know. I'm not that slim. Teh tarik is the best. Teh tarik okay, but manis sometimes, too sweet. Depend on shop also.
Then teh tarik kurang manis.
Cook. Some people they cook the tea. To become teh tarik, they cook the tea. Then only they tarik at home. Long Maneng already do his work. Okay, wait Long Maneng. Mana ni? Number... Number 7. Okay, jot down first the information. Quite a lot, you know, the information. Wait, I check how much. 742.22 kilojoule. Yes, correct. I cannot reveal to other people. Later, they lazy to do. For me, teh tarik cannot drink at night also. Later, difficult to sleep.
Miss, you provide trial exam paper.
Exam paper? What?
Trial exam.
How?
Trial exam.
Trial exam?
Yeah.
Oh, you want to do some revision on past year's question, can?
Yeah.
But cannot upload.
I was asking, do you provide?
Provide cannot. can do in class some of it. Why?
Don't feel ready for exam.
Huh? Still long lah, 3rd of November.
Yeah,
1
but
month
then
more.
feel like did not enough exercise.
Not enough exercise. You just pray it won't turn into hard copy lah. APU every time do things drastic. Today study, another 1 day or 2 days already implement. Since we are going into the APU on the 18th this Monday, so we will see what is the meeting. If they require all the online exam become not online, then I will inform you. Everything learn on the spot, you know. APU very good in doing all this. It's good for lecturer to do it fast lah, but sometimes the time given is not enough. Suddenly change format, all must follow. So hopefully, since your exam date is already set the time, maybe still online. Don't be scared. It is related to the tutorial question, related to slide. Okay?
Hi, Miss.
Hmm.
Like last class, right? You said about the 4B. Did you find out yet for the how large are the gaps at negative 20 degrees for this tutorial? Question 4B.
Oh, I forget lah. The one that need to -2 or what ah?
That question you said either need to plus 60 or plus 40. That question. Yeah, 4B that one.
I remember. 4B ah. Okay, I haven't look into it. Next class lah, I inform you.
Okay, Miss.
Okay, question 7 finish ah? Only long man hang finish. Okay, the rest. Information to jot down first, this one. Number 7. TC 15 degrees Celsius. T 100 degrees Celsius. So changes of T 100 minus 50. 85 degrees Celsius. You do this one, Masho. Okay, working. After Q, how much? Next is M kettle. M kettle 0.4 kilogram. Mass of water 2 kilogram. Kilogram of water with 0.4 kilogram of aluminium tea kettle. Bani give answer already. Okay. For those who have finished, you can snapshot your answer. Total M. Total M at the water M with the kettle M. 2.4 kilogram. Water specific heat 4.186 kilojoule. Kilo must include in calculation. Heat for aluminium Aluminium C, 0.9 kilojoule. Okay. So Q needed is Q kettle plus Q water. So do one by one. MC changes of T plus MC changes of T also. Next, substitute. Substitute M 0.4 for kettle times with C 0.9.
Miss, then what's the point of finding the total mass?
Huh? Which one?
Then
Oh, this
why
one
do we
ah.
need, yeah,
Why now?
why, yeah.
No need to find. If find, you can factorize this ah. This can be factorized. M total. 2 plus 0.4 put outside. Can also. This one put 2 times, right? 0.4 plus 2, 2.4 put bracket here. Can also. Okay. Depend how you calculate. For exam also, there are some students who use another method. So we must check whether correct or not. Okay. So even though the working is not the same as marking scheme, but if the answer is the same or nearly the same, can be considered. Unless second marker is strict. Whatever not in the marking scheme, he will not take it as marks. There are some lecturer which is strict also. Last time during my university, got one sent by Bania. During university, we have option, from 5 questions, choose 4. Choose 4 for final exam. But there are some students who do 5. Then will the lecturer mark the first 4? Or the lecturer will mark all and select the best? If I am the lecturer, I will mark all. I select the best. Because student also difficult, right, to get A. So he was trying to get A by answering all. But he don't know which mark will get more. Number 1, number 2, number 3, number 4, number 5, got 5. Yeah, some lecturer will mark first 4. If too many students, cannot lah. APU still okay, not so many. Okay. Last time I work in other college. In 1 year, if exceeding 650 script in 1 year, then only can claim. 1 paper, 5 ringgit. So that one a lot of student. If not, cannot claim at all. APU cannot claim. Any amount of student cannot claim. Okay, like industry 4.0 subject 71 student. Mark all lah, no claiming. That is part of our duty. Okay, this is sent by Bunny. Okay. Okay, other have finished number 8. Okay, those have finished, continue number 8. You know, there are cases where student brings formula inside their pocket. Then the student go out early. During the exam, go out 1 hour, half an hour earlier. After half an hour, cannot already, right? For example, exam start at 2 until 4. So 3:30, before 3:30 can go out. After that, must wait until 4. So, during that exam, my student, the formula come out from his pocket. I don't know he refer to the formula or not, right? But there are some other invigilator who see it. So cannot cover already. Other student also see. So need to bring him to the report lah. So suspend for 1 semester. You don't know, but try not to do all this. Okay, it will make you suffer. Luckily, don't kick out from college. Only suspended 1 semester. Also need to retake the subject, not resit, retake. Retake means need to attend class also, not just take receipt. Okay, so be careful for subject which have a lot of formulas. Be careful. Sometimes you want to help your friend. I have seen videos of APU student passing formula from back to front. Because in APU we have CCTV in the hall. So during your lucky time now, which you do online, all the exam, the quiz, okay, try to score. You will not have that chance anymore. Okay, if you are a good student, never mind. Anytime also you can score. But not all students are good in all subject. Maybe they are good in certain subject only. Subject which need a lot of memorizing, they are good. Subject which need concept, they are not good. Like programming, all this need concept, not good. For me, I teach robots also. So, student need to be tested in the lab test. Student do on the spot. Assemble component, assemble sensor, assemble motor, all. After that, on the spot must write the program and upload to the robot. If not working, problem ah. So hands-on exam or exam which is practical like this need a lot of understanding. Okay. Nowadays a lot of sources you can learn from video, from YouTube, from friends, from brothers. So try to study from beginning. Okay, now we do number 8. Compute the heat of fusion of a substance from this data. 31.15 kilojoule will change 0.5 kilogram of solid at 21 degrees Celsius to liquid at 327 degrees Celsius. The specific heat of the solid is 0.129 kilojoule. Compute the heat of fusion from this data. Just now, heat of fusion Must include the LF. So they are asking you what is the LF? Okay, jot down first the information in question 8. What 22.26 correct? 22.8 kilojoule the answer. So from all the chapter, you don't know which chapter come more. You cannot, I cannot say it is equal lah. There are certain chapter with more questions, certain chapter not much question. It was selected by the second lecturer. After we set the question, we send to one of the lecturer who teach the same subject. Then we send to the academic leader to check again whether it is up to standard or too easy. If too easy, academic leader will make the changes. Number 8. Okay, number 8, jot down the information. Q is 31.15. $327. Changes of T is 327 minus 21, which is 306. Okay, after that, calculate Q equal to MC changes of T plus M times LF. Any other feedback? 22.826. Okay. So finally 31.15 is the Q minus M 0.5 times C 0.129 kilo times with changes of T 306 divide by M. M is 0.5. Total 22826 change to kilojoule, 22.8 kilojoule. Also you can answer 22.82 or 83. Okay. Okay. Finish, ah? So now we will do past question, which in the question D here. 6 marks for question D. Another one is 5 marks for question E. Okay, try to settle this question D and E. After this, we will discuss. Okay, I leave it to you to do this first. Okay, some have given their feedback 203.41 for the question D. Okay, question D. This is recently, June, the exam. Okay, so see the marks, how the marks is given. This one quite generous. Working 1, answer 1. Okay, working to minus got marks. Okay. So 960.8 minus 100. Okay, if you don't have this working, you miss these 2 marks. Some students, these 2 don't write. So directly they write here only. Here only this mark here. So you 2 marks will be gone. Okay, that is why I said, if you are not sure which one have mark, which one no mark, you write everything that you can. Okay, so total change of solid silver. Q equal to MC changes of T plus MLF. M is 0.7. Okay, compute the heat that must be added to 0.7 kilogram silver. So here is the 0.7 times with silver specific heat of silver 0.235, and then multiply by changes of T. Okay, after that,
Can scroll up a little bit? I want to see the first mark. Where does it go?
question DE.
No. For the marking scheme. And expand the.
Marking scheme only this one.
Isn't this total 5 mark only? I think.
Yeah, 5 lah. Yeah.
I thought the markings. I mean the marks.
6.
6.
Oh, here.
Oh, okay.
1, 2, 3, 4, 5, 6. Okay, so after you substitute, you will get this 203.41 kilojoule. Okay, no problem all. Question D. Okay, next continue question E. I want to give you a tips. Within 1 year, we cannot repeat the same question. Within 1 year. So this one just finished in the June. Okay, so it can be changed to another value or with pictures as long as it is not exactly the same. Concept, okay, can be same. But this one, 11 marks is simple compared to other chapter. Okay, other chapter, temperature and heat not so challenging because they don't have to twist here, twist there. Chapter which are difficult, the one which you have to calculate the area. Because area, maybe you don't know the formula for area, later you don't know how to do. Number E, a 2 kilowatt heater is used to heat a room from 5 degrees Celsius to 20 degrees Celsius. Our case in Malaysia, we don't use heater, we use aircon. Normally, how much the aircon temperature that you put when you sleep? Not sure. Huh? You put 18 ah? 18 too cold lah for Malaysian. Malaysian all small size. If Englishman, never mind. So I think
20 oversized.
20. I put
25.
22 or 23 lah. In the car also like that. I cannot put until 18 or 20. It is too cold. I no aircon. Tipu lah. Kereta kon, really ah, kereta kon. Kereta kon, I have this. It is a small aircon which I can put in front, next to the laptop lah. Okay. Buy from Lazada or Shopee lah. Can put water here. Become like air cooler lah. But very cold, very cold. And quite cheap lah, 30 or I don't know. This is the size. Can bring anywhere. In case I go to anywhere which don't have aircon or what lah. Then you have the USB cable. You can bring power bank to go for camping. Later got mole. Green lah. I use one standing fan in my room je. Oh, if your area got a lot of trees, okay lah. Maybe cold. Nowadays my area not many trees. Only the trees at the roadside where the government tanam one. Genting Highland ah. Finish number E. Calculate the minimum time required to heat the room. Last time even the taxi have fan also what? In front there. The old taxi lah. If they give kilowatt, then it's time second or hour. Oh. Second. Second also lah. Time always second. Yeah, must use SI unit. So, wait You must use the P times T equal to Q. Oh, that one just now don't have right in the slide. Formula for the power. P equal to PT equal to Q. Q equal to P times T. $225 seconds. Yeah, the answer is 225 seconds. But before that, you must calculate other thing first. Hmm. You need to calculate the Q first. Q equal to MC changes of T. So unit is what? Right, not kilo. Joule per watt.
Miss, the P stands for power,
Yeah?
right? The P.
Yeah, power.
So
Yeah,
it's in watts, right? W, right?
Yes.
Okay.
So given 2 kilowatt, you need to times 1000 lah. 2000 watt. So the value divide by 2000 watt. Oh, rajinnya Samuel type. PT equal to MC times changes of temperature. Where is the 4.5 ah? Tak ada Samuel cannot do shortcut like that. Later no marks for the 4.5. Yeah, your final answer is correct, but later you get 3 marks only. For the top part, you don't get.
Means on my paper I got right lah. I got right. 20 Celsius minus 5.
30 times 1000 times 15 equal to 4.5. Actually, you just missed the 4.5, right? Okay.
Miss, what 4.5? Is it the Q?
Q, yes, Q.
I got 450,000 for the Q.
Same.
What? It's same, right?
4.5 times 10 to the power 5.
Oh, okay.
Means is it important to get the 4.5?
Wait, means so meaning we need to
got
count
mark.
the Q separately.
Yeah, to get the marks.
If I put all one.
All one here only lah. Ni the marks 3 lah. Got marks but 3 only because the top one is 2 marks.
Oh my god, like that.
Understand
No, okay. No, but I start with the formula P equals MC PT equals MC theta already. Then I start with the full formula.
C equal to MC theta already I don't know lah. Sometimes we can give full marks, depend on lecturer. If I give full mark, later second marker minus 2 mark also. If you are lucky, you are chosen the 12. Your class how many? 14 Or is it 11 Because only 12 script will go to the second marker, including the tutorial, including the assignment, including the quiz. The same student, the 12 student only. So if your class only 12 student, all selected So mostly second marker will try to find some changes whether increase mark 2 or 1 or reduce marks. Because must show do work what? Later check, no change. Like no work also. But actually, final exam difficult to reduce marks but assignment easily can increase. Only the presentation part cannot decrease. So student who are good, I will give high mark for presentation, since second marker only can change at the report. Unless she require us to record the presentation, want to see the video, so can share the video of the class presentation. There are some fussy lecturer also want to see. So in our work, we must be sincere whatever we do. Okay? If we sincere, everything will be fine. Okay, 4.5 already. After that, the 4.5 substitute here. 4.5 times 10 to the power of 6. To the power of 5 or 6 Oh, here I already 4.5 change to 45 times 10 to the power of 6 divide by 2000 is 225 seconds. So that is the style for the question which involve last chapter. See.
So is that all the questions for today, miss?
Got one more, wait See, oh, this one quite long lah. Question number C here. But the answer quite long. Later we do in other class. So there are another question involving heat and temperature. Metal rod heated from 30 to 90. Final length of rod, the coefficient of linear expansion is this. Compute the initial length of the metal rod. Total marks 5 only. Okay, let me show you. Even though the working is long, we got many lines, right? But student might not write all this. Okay, they might directly write this. So we have minus the marks which is allocated here. And just leave it here. So about 2 lines for 2 marks. This one final answer 1 mark. No marks given for this part. Okay. And then other formula which is not in the formula sheet. So 1 mark can be given for that. Mean you already expand from whatever in the formula sheet is not there, or expand or you manipulate, you get 1 mark. The sheet cannot get marks. So even though you see the question is just 3 lines, it looks simple. But the calculation since you need to write down what is the information first, that one like no marks lah. But here the minus of the temperature got mark. For the question just now is 2 marks, right? One for the minus, one for the final. But this one got 1 mark only. But must show. So that value after that put inside here already. 60. So if you don't write this, your marks will only be here. Okay, so be careful of the working step. The step, write as many steps as you know. Because you don't know that line got marks or not. Okay. So this we will do in other days since not enough time to do now. To take attendance first. So other days we will do some revisions and also to hear about your presentation of assignment.
This
How's
is the
your
answer.
progress?
This is the final answer for the 1666.
Just now one
Yeah.
Oh wait 101.
Oh yeah, right wrong. Never mind.
101.69. Question already take take picture lah this one. If not later you watch the video you can pause. After pause take picture then can do. Okay. Wait the attendance. Friday. So you are not going to campus or what next week? I see the list don't have your class. For the hybrid one. So Monday onwards, most of us will be going to campus already. Except for classes which is fully online. Yeah. Your class all fully online or only my class? All right. Because your cohort about to finish this semester. Okay, thank you all. For those who have scanned, you can leave.
Thank you, Miss, and have a nice weekend.